You, as a professor, as a lead researcher, can definitely give a lot of folks here perspective on the machine learning path. Does it make sense to do a PhD these days? And if it does, who do you have to be in terms of fit, not necessarily demographic or whatever, to really achieve a lot?
Well, as for whether to do a PhD or not, I think it depends on if you work in, say, cutting edge AI research versus maybe using existing AI research to make impact in the real world. If you want to use existing AI research and figure out how to apply it to real world problems and build a company or apply it for some kind of social good, then you don't really need to do a PhD. If you particularly want to work in cutting edge AI research, then you probably have to do a PhD. So I think that's the main thing for people to think about, kind of what their career goal is in that respect.
Welcome, Dr. Timothy Hospedales. Thanks for joining us today, Timothy.
Thank you for having me.
Fantastic. So, we always like to start the show with sort of how you think people from the Caribbean diaspora, at home and abroad, can get into the field of machine learning and tech in general. Any quick thoughts around there?
On how they should do it?
Just like, why? Why should we start?
I mean, it's a fascinating subject, and you can make big impact these days. So there's no reason not to.
Fascinating subject, big impact. Great. Let's start a little bit with giving us a bit more flavor of what you're working on right now and a bit about where you're from originally.
Sure. So I'm from St. Anne's on the outskirts of Port of Spain in Trinidad. And that's where I started. And I work in AI research nowadays. And I guess my research topics are how to make models that are robust to real world data. So you don't want to have the kind of embarrassing problems that have happened recently where like face recognition goes wrong in embarrassing ways, or the self-driving car runs off the road, and etc. And you don't want to have models that are vulnerable to adversarial attack and so on. So how to make them robust to the real world and not only function in the lab is the first topic. And the second topic is how to build AI models from sparse data. So as you know, everything is all about big data hype these days, but many of the most important problems don't have that much data, whether it's like studying medical diseases or studying data sets to do with small island states rather than big countries. So it's important to be able to work with small data as well. And also because humans can often learn from very few experiences of something. And so to the extent which AI can't do that, and AI needs thousands of examples where a human needs one, then understanding what we are doing wrong in AI that where we need 1,000 examples that humans don't is a kind of fundamental question to understand, like how to use AI to emulate human intelligence.
Wow. And I think you are the head of a lab, correct? I'm going to re-pull up your LinkedIn here. And can you tell us a bit more about how many students or folks you have under you directing research?
Sure, yeah. So I'm a professor in Edinburgh University in one hat, and there's about 10 PhDs and postdocs in my group in Edinburgh. And I'm the program director for machine learning at Samsung AI in Cambridge, and there's about 5 staff there. But we are hiring, so feel free to email me if you have an AI PhD and are looking for a job. And so those are the people who I work with.
Remote job?
Well, unfortunately, it can't be remote. It has to be in UK. We've been begging them to support remote working, but so far in company side, there's some administrative problems with that.
Okay. We'll hope things change, but if anyone on the call, you have a plug now. So what motivated you, aside from fascination, I would say, and impact, motivated you to get into machine learning? Because at least before knowing about you, I didn't know that there were so many Trinidadians and some other folks in the group that were such preeminent researchers in the field. So it's really exciting.
Yeah, it's an exciting field, and also I didn't know too many trainees until very recently, so it's been really exciting for me over the last couple of years to get to know more and more of the diaspora. So that's been great.
Cool.
But coming back to your original question of what motivated me, I guess I was interested almost since I was a child, because it struck me that human intelligence is one of the underlying forces that shapes the world. You know, people go on to build businesses and invent new technologies and explore to new continents and everything. All of that stuff is eventually underpinned by human ingenuity. And so it's kind of a fascinating thing to understand. It's also one of the biggest mysteries in science, because human intelligence is very poorly understood. And so we can try to study that through neuroscience, which is something that I had a small foray into. But the other side is to try and study it by emulating it artificially. So yeah, that's something that I was interested in almost since I was kind of like doing my common entrance exams we have in those days. I don't know if you guys still have that. Yeah,
I was lucky to be around in the common entrance before I think it turned into CSEC or whatever they call it these days. And can you give us a highlight journey from high school? You came from St. Anne's, and kind of give us a flavor about what Dr. Hospedales was like back then. I'm sure your grad students are always interested as to, hey, were you a slacker in school? Now you're this big researcher, up until having both a dual role in Samsung and as a professor as well.
Yeah, I guess I had a fairly traditional path. I kind of went to CIC and was a bit of a nerd and studied hard. Then got into Cambridge and carried on being a nerd and studied hard. Then I went to Edinburgh for my PhD, or for 2 master's degrees and a PhD. And at that time, I learned a bit like how to party and stuff, and that was much better. So that and yeah, people always ask me about what other things I do and how many papers I published during my PhD, and I could probably have published more papers in my PhD if I had not learned to have a social life by then. But in the end, I'm glad that I learned to have a social life by then. Yeah, so that was good. And then I eventually got a faculty job in the university and worked my way up to professor. And in the last couple of years, I now have a dual role, and I've been exploring the kind of corporate research world as well as the academic research world.
How did you sort of make that foray into industry? Is it just from grants, or was it networking?
Well, in the AI field, we are lucky enough nowadays that there is a lot of interest from industry. So once you build up some kind of academic profile for yourself, if you do a PhD and you have a couple of publications, like people basically, recruiters start chasing you down. So in my case, I guess I got a bit tired of all of the paperwork and administration that happens in the university. And so at some point, when one of those people came knocking, I was a bit like, okay, let me answer your call and see what they have to say. And they convinced me to give it a try. And yeah, there's pros and cons of each world, which I can talk about if you want. But yeah, it's been super fascinating to bridge the divide.
Wow. So in St. Mary's, were there any teachers that sort of motivated you to pursue certain subjects, or you kind of internally sort of knew you wanted to do computing and I guess math, physics, and that's what you did in CIC, right?
I was strongly motivated since childhood. As I said, I had some teachers who kind of were very nice and encouraging, and like Mrs. Dean, I don't know if she's still around. Very nice and encouraging, teaching me math and further math at A levels. And then there were some other teachers less encouraging, like Father Leifuk. Maybe he's not still around. He was very old when we had him. But he always, used to tell us that we were not clever enough and we should go home. So I guess that's a different strategy of some teachers, to try and like challenge you rather than encourage you. But anyway, the mix of those two, I eventually learned enough math from them.
I think he was preparing you for the PhD, essentially.
Yeah,
right?
exactly.
And yes, Father Leifuk is quite an incredible guy. He was a PhD mathematician as well.
Yeah,
correct?
Yeah.
Wow. And so you're playing this dual role. What was your experience like? Let's take a little shift into your PhD. right? You did your master's, and
Mm-hmm.
I guess you've had this interest and wanted to pursue it further, and that's what led you into the PhD.
Yeah. So actually, around then I was debating whether I should pursue my interest in intelligence from a kind of neuroscience perspective or an AI perspective. So I actually did a master's in neuroscience, and kind of learned a bit about like cutting open brains and sticking in electrodes and all of those like more complicated things you have to do in neuroscience. And I found out that it was very interesting, but it's quite slow and painful. No matter how bad you think it is when your code crashes and then you need to recompile, like when you're digging into someone's brain and playing with electrodes, like everything is even worse than when your code crashes. So yeah, I eventually decided that I was too impatient for the neuroscience approach, which is quite hard labor, and to focus on AI. And yeah, I really enjoyed PhD days. You get to kind of focus on a particular problem, and I mean, can be a little bit solitary, but if you find a problem that you like and are willing to stick with it, definitely there's always a lot of setbacks, and I think people maybe overestimate how clever you have to be to do a PhD. The main thing is to have a lot of grit to like stick through all of the setbacks and carry on persevering even when things don't work. And then yeah, by the end of several years of study, they will surely work if you can kind of carry on trying without giving up.
Yep, all the paper rejections, conference rejections, and
exactly.
Oh, those are interesting experiences.
Getting scooped when you like naively go to a conference as a fresh-faced PhD student and tell everyone your best ideas, and then they go away and do them quicker than you. And yeah, there's all of those different setbacks. But yeah,
that's a good lesson. Don't share too much in the academic realm, I would say, unless you've released your archive paper.
Exactly.
Right. So I actually wanted to ask a little more about the PhD, because I think you as a professor, as a lead researcher, can definitely give a lot of folks here perspective on the machine learning path. Does it make sense to do a PhD these days? And if it does, who do you have to be in terms of fit, not necessarily demographic or whatever, to really achieve a lot, right? Or to maximize the time investment that you would make?
Well, as for whether to do a PhD or not, I think it depends on if your goal is to work in, say, cutting edge AI research versus maybe using existing AI research to make impact in the real world. If you want to use existing AI research and figure out how to apply it to real world problems and, you know, build a company or apply it for some kind of social good, then you don't really need to do a PhD. If you particularly want to work in cutting edge AI research, then you probably have to do a PhD. So I think that's the main thing for people to think about, kind of what their career goal is in that respect.
And most of the students, what's it like to get a PhD with you? Like, what are you like as an advisor? Are you very strict, or how have you developed from your PhD into an advisor?
I think I'm probably very lax as an advisor. I don't like I tend to try to get people who are self-motivated and then let them get on with it. I don't try to like give people strict deadlines or you know, bully them and shout at them. Some of the other advisors can be a bit like strict in different ways, but I'm very lax.
And your students, they vibe with that. And how many students have you graduated so far?
I have graduated, I don't know, about 8-ish so far. Need to double check, but yeah, around that many. Yeah.
Wow.
And yeah, I guess it depends a bit on the attitude of the students. I mean, one thing I've learned over the years of being a, let's say, research leader, when you get to that point, is that it's not one size fits all. Different students need different things, and kind of trying to work out what different students need and provide them the right kind of support for the sort of person that they are is one of the tricks, rather than trying to fit everyone into the same mold. So some kind of students might be, let's say, super, I don't know, bad at procrastinating. And so then you need to like do more of setting them small tasks so that they kind of carry on doing things and they don't just browse Twitter all day. and other students might not have that problem at all. And if you micromanage them by setting them small tasks, then it will also be a problem. So I think everything is just about like working out what kind of support people need and giving them the support that they need.
So what I'm hearing is, as a student, if I come to study with you, I essentially need to know what are my strengths, weaknesses, and sort of learn to flex with you as I go along in the PhD process.
Well, I mean, that would be great if they could tell me that in advance. Normally, they don't know that, and that's part of what I have to figure out is the support that they need.
Okay.
But yeah, if you also can tell me that in advance, that'll be even better.
Wow. And I think just reflecting on my own sort of experience, when I did my PhD, I didn't know what the hell I wanted to do. I just knew I wanted to get one and get out. And so I just followed my advisor's lead. So at least for folks that maybe are not as self-directed as you were in terms of, hey, I knew I wanted to do this. For me, it was you do this or like you have no other options. I'm like, okay, get it done. Just following your advisor's lead. What would you say is how important, and in a percentage basis, is the advisor when choosing a PhD?
Percentage basis, huh?
Yeah.
I don't know. I mean, there's a lot of factors that go into it. There's like the reputation of the institution. There's the facilities at the institution if you are doing something that needs certain equipment, and then the advisor. But even the advisor themselves is a complex beast. So, for example, when I did my PhD, I was the first student of a young advisor at the time, and so then that meant that he had a lot of time to work with me. So if you choose, let's say, a very young advisor, then it might mean that they don't have a big reputation to share with you yet, but they have a lot of time to work with you. Whereas if you go to a PhD advisor who is very senior and very famous, you might see them once a semester and you can kind of like borrow from their reputation, but they might not be around much to give you advice. So even like, and so then the choice of advisor can then also depend on which of those kind of approaches that you like. If you are someone who needs help with direction, then maybe it can be good to get a younger advisor who has time to work with you. If you are someone who's very self-motivated, it might be good to have a senior advisor who you can kind of borrow their reputation and then but not rely on their kind of daily advice. So there's different kinds. Also, sometimes you can get a particular topic which is like well aligned with the advisor's expertise, which can be helpful because you can draw a lot on their experience. Or other times, PhD advisors or professors use having a PhD student as a way to learn about a new topic. And so you should be clear about which of those you are getting into. So in my case, I was my PhD advisor's way to learn about a new topic that he didn't know about. So although he was young and had time to work with me, he didn't particularly know all the details of that topic. So then I was kind of left swimming in the deep end quite a lot from day one. So yeah, there's many different facets that go into how it works out. But I think, a lot of those things are very mysterious if you are just applying for PhD programs, and all of those facets are probably like things which you only see in retrospect. It's probably like hard to get it right. It's probably hard to like plan all of those things to have them work out exactly the right way at the beginning. So I guess the main thing is just to, you'll need some grit to kind of overcome the things that don't work, and some kind of willingness to roll with the things that do work, and then try to make the best out of whichever PhD program you do get into.
Makes sense. That actually helps a lot. And even in my own reflection, I was my advisor's first student. So I did have a lot of that time for grooming. And as I've seen him rise in his own reputation, like he has much less time for the students now. And so for folks listening, if you want to pursue a PhD, try as much as you can to get to know your advisor in advance and be very clear about what it is you're getting into. Don't be too cocky.
For example, in my one of some of my first students, I wrote so many thousands of lines of code for them when they were struggling to implement something or other. And now that I have 10, then I don't normally have time to write code for them or help them debug their code or whatever. So yeah, it's normal that like different advisors at different career stages will have different amounts of time to do things.
Wow. So you've finished your PhD, right? How many papers did you finish your PhD with? Curious. Yeah, you see, that's interesting. You can't even
Three.
remember now.
Three.
So 3. Wow.
Not like a huge number, especially by contemporary American standards, but like adequate.
Yes. Can you talk a bit about what you see the differences in the process in the US versus you did yours in Scotland? Is that correct? I think.
Yeah, yeah. Well, I don't know a great deal about the US because I did
Okay.
mine in Scotland, but my impression is that in the US you have got a bit more time, and in the UK they like to kind of rush it through in 3 years. So you have to
Wow.
be a little bit more focused in the UK, and it's in a way like, so in the US, let's say the graduation requirements might be a bit higher, but at the same time, you often have several more years, if necessary, to kind of get through all of the things. Whereas in the UK, this 3-year thing can go by like a flash. In the first year, you are trying to like read some literature and figure out what's going on. And then like you kind of have second year to do some work. And in the third year, people are asking you about writing your thesis already. So it's just
Wow.
like you kind of have the 1 second year to actually do something, right? So it can be a bit of a rush. And then once you graduate, there can be a little bit of a problem that if you graduate from a UK-sized PhD, you might have 3 papers or something, but then be competing with Americans on the job market who have got like 10 papers or something if their PhD went on a bit longer. So,
And how helpful is it usually when you hop in under an advisor, you tend to be part of a lab, right?
yeah.
Have you seen edge cases where that's not the case?
I mean, different advisors or professors, research group managers like to have different sizes of labs. Some of them like to work very one-on-one with whoever student they have, so they only have like a couple of students at a time. Others like to grow the biggest labs possible, and so then they have so many people they can't remember everyone's name, and they certainly don't meet with them all.
The factory.
And sorry?
I said the factory model, right?
Yeah, the factory model, exactly. So yeah, the experience depends a bit on what kind of lab you get into. But I think most of the time, especially nowadays, like it's less common that there's only 1 or 2 PhDs. There's normally like quite a few. And so it's always good to kind of make friends with the senior PhDs and postdocs because you can really learn a lot from them. I certainly learned a lot from the postdocs in my lab when I did my PhD. And nowadays, I also try very hard to kind of apply for some funding and get some postdocs and then help them to kind of mentor the younger PhDs as they are coming up. So
that's beautiful. So let's talk about postdoc. I had always been a little kind of like, postdoc, and that was just my own bias against school, but it seems like it was probably a quite enjoyable process for you to a degree.
Yeah, postdoc days were pretty good as well because you didn't quite have the whole thesis thing hanging over you. So then you just got to like pick your research topic and kind of dive into things which are interesting. So yeah, I really enjoyed postdoc days as well.
And so when you go to produce new research at least in your side of the field, how much of it is actual new math derivation versus, let's say, a new neural network architecture or some other application of a known theorem, if you get what I'm saying?
Yeah, that's a good question. Of course, I mean, AI research nowadays is a very broad thing. From there's the whole like spectrum of things that are highly theoretical to highly engineering, and all of them are valuable and all of them have their place. Personally, in the kind of portfolio of things that I do, I guess we are somewhere in the middle. Sometimes we are deriving new mathematics. Sometimes we are kind of making new neural network architectures. But there is also interplay between these things because sometimes like playing with the right equations and deriving some new mathematics suggests a new neural network architecture that you wouldn't have thought of otherwise. And sometimes the particular efficacy of a particular neural network architecture kind of suggests you some kind of math to think about. And then you can end up like making some equations to explain why it works. So there is an interplay between the two sides. And I quite like being somewhere a little bit in the middle.
So would you say you're a stronger mathematician or a programmer?
I guess, well, now I spend most of my time being a manager.
Okay.
But I guess in PhD and postdoc days, I was probably somewhere in the middle.
Somewhere in the middle. Okay. Yeah. And what were the things that, this is something that's always been interesting to me, and I think hopefully it is for the listeners, in terms of how do you push yourself to get better in math? It's one of the weird, like programming is, I think, a little more straightforward in terms of how you progress. How do you progress in math, right? You just take harder and harder courses, at least bounded in the world of machine learning.
Yeah, that's a really good question. Well, I always, there was a lot of math, like, you know, from high school to undergrad and everything that at the time I could never see the application of. And then I was like, in A levels and CIC, they were teaching us all of these, like, you know, calculus things and linear algebra and stuff. I'm like, why do we want to do any of this? And no one could give me a very good answer. And nowadays, I wish I had paid more attention to all of every math anyone ever tried to teach me turned out to have a use, even if I couldn't see it at the time. So first thing I would say is pay attention to all of the things that people try to teach you in school and university. There are uses for all of it, at least if you go into AI research. And then, yeah, how do you push yourself? I guess I was quite interested in just sometimes you get a model. I mean, it's a bit less the case in current deep learning era, but before, when, you know, people were doing a lot of like Bayesian approaches to AI and so on, then I was quite interested in just like deriving every model that I came across from first principles. And then doing that a lot kind of gave you a lot of practice in how to go through these things, and so then you can more easily derive new models to solve new problems that you come up with.
So you would look at a particular solution and then try to sort of resolve it yourself in a particular direction? Sure. Okay. Nice. There was a question that I forgot to ask in the beginning that I think we usually try to set the tone in terms of definition and make sure, at least when we're talking about certain things, everyone is aligned. So what's your interpretation of AI versus machine learning versus data science?
Yeah, that's a good question. I guess, so we should start by saying that A, the lines are blurry, B, different people use these terms differently, and C, the uses of the term has evolved over time. So I advise people not to get hooked up on any like very particular definition. But with that caveat, I like to think about AI as trying to simulate the kind of information processing tasks that humans or animals do. So whether that, and that can be different things from calculus to recognizing your mom or balancing on two legs. All of those are processing different kinds of information in different ways, and we are trying to simulate that in AI. And machine learning is a large part of contemporary AI, but not the whole thing. There are other parts of AI that are not machine learning based. There's expert systems and logical reasoning and things like that. So I view machine learning as like a sub-component of the AI, which is addressing this broader thing of simulating the information processing. And then data science I view as being a bit more general. So it kind of often involves AI and or machine learning, but it also addresses things that support them and make them work smoothly, whether that be kind of making sure the data is well organized and you know, flowing nicely through the compute infrastructure, and making sure that the insights that they generate are well communicated to the senior managers and whatever. So I view kind of it as also supporting AI and machine learning.
Okay. Wow. Thank you. And for folks listening, at least every episode that we sort of put out, you're going to hear slightly different, I would say, but take away that it is flexible and to make sure and realign when you speak with someone. Coming back to your career journey, right? You finished your postdoc and you stayed on to teach, it seems like, in the same college. What was it like being a professor, right? You were a slack student drinking all over the place, you know, liming and producing papers. And now you have to be like, okay, you need to be a serious student and maybe don't do what I do. I don't know.
Yeah, that was maybe the biggest shock in the career trajectory so far. Everything else was kind of like on a similar trajectory. But then all of a sudden, when you become faculty, you have to worry about teaching and administration and all sorts and all of the weird stuff where, like, the first couple of times I went into the classroom, the students refused to believe that I was the professor because I was still looking so scruffy. So they told me to sit down and stop like standing at the front of the class.
Wow. And that legit happened?
That legit happened, yeah.
Very interesting. Actually, I wanted your perspective on this, right? One of the things that I struggled with during my PhD was you sit in a lab all day. You sit in this one room for years. by yourself, maybe with your couple of lab mates, but everyone's going through their own struggles. And one of the things that I did to sort of lift my perception, I had always asked for advice from different professors, was to dress for success, right? So I started dressing as if I was ready for work, and my advisor looked at me like, what the hell is wrong with you? Like, where are you going? You're coming to the lab. And I just refused to sort of settle for that. I'm like, no, I'm preparing for like life after this PhD because this is insane. What were your strategies to sort of, keep the grit and keep you mentally sane in a PhD?
Well, I do not have your style. I definitely didn't try to dress for success. Maybe I should have I should have done that. I think, well, I mean, in my personal story, what happened to me around that time is, as I said, I kind of stopped being so much of a pure nerd by then. Actually, I took up social dancing at the time.
Oh, nice.
So I have since been a very passionate Argentine tango dancer for 20 years or so, since I was starting my master's degree. And I think it really helped to just kind of go out and do something so totally and completely different from writing code and proving equations. That was something which helped to kind of keep me a little bit grounded and at least just change mental gears a bit, so that then you could go back being a bit more refreshed to your coding desk.
And do you sort of advise that for students? I personally advise, hey, you should have kind of like a sub life. It's not another life, it's a sub life to your PhD at least, and to help keep you sane.
Yeah, I definitely advise that people should have something, whether that's like, I mean, yeah, I do like running a lot recently is good. You should do something which, when you do it, will completely occupy your mind, so that there is no way to kind of carry on ruminating over your work while you're doing it. So if you like go for really hard running, then you need to focus on keeping your legs moving. If you go for, I don't know, weightlifting or whatever, and you need to focus on picking up the weights. Recently, I had the privilege to learn some kite surfing while visiting the Caribbean.
Oh, nice.
And you really need to pay attention to not get like dragged off your board and like slammed into the waves. Like you can't carry on ruminating over work during those things. So I recommend that people have something that they do where it's like physically impossible to think about work while you're doing it.
Perfect. And did you take a lot of naps in your PhD? Just curious around that. I took that from the culture. I had a sleeping issue in school, so throughout my entire career, even in work now. But just curious if that was a strategy of yours.
I don't recall doing that.
Okay. I used to sleep under my desk like multiple times a day, and that a lot of people made fun of me for that. But that really helped me to just, I could work for most of the day actually, instead of going home and sleep, just fall asleep on your desk and keep going.
Sometimes I find like right after waking up, you have quite a nice fresh mind. So like having a little nap and then exploiting that just waking up bump can be a good thing to do.
Yes.
But I remember they sent around a lot of emails saying that sleeping under the desks was not allowed.
Really?
But I wasn't one of the ones who was doing that personally.
Okay. If I was in that school, I would definitely be getting kicked out or something. So you went from a lecturer to a senior lecturer. I guess by that time, folks didn't think that you were sort of kidding anymore, and you were the professor. What does it take to sort of rise the ranks in a college in the UK?
Yeah, I guess, well, to get the PhD, you have to get a couple of publications.
Okay.
To get the postdoc, they have to be decent publications. And then to get from postdoc to lecture, you have to have a few more publications. But then to start rising the ranks of faculty, the requirements change a bit. They start to care more about like what are your teaching review scores, and sadly, but very importantly, how much money do you bring in terms of grants and stuff. So you kind of have to do a good job of mentoring and graduating PhDs, continue to do good research, but then you also have additional tasks of teaching and bringing in grant money.
Wow. And I guess the higher you rise, the more you're expected to sort of keep that bankroll and money coming into the school.
Yeah.
Wow. And once you've switched over, let's say now you're a principal scientist running that group at Samsung, how do you, like, what does that mean now? You bring money in to the school through Samsung, from Samsung, or they give you time to just continue teaching and you buy out your classes at school?
So I bring a bit of money into the school from Samsung, but mostly just because Samsung pays for most of my time.
Okay.
Then all of the stuff like teaching is bought out. And so I just have my kind of like for fun research tasks in the university. So that was my attempt to organize my work life to align with the things that I enjoy doing most.
And you negotiated that, I imagine, right? Or is that...
Yeah.
So for folks who finish their PhD, become a senior lecturer, and you want to break into industry, make sure to negotiate for some of the things that you enjoy, it sounds like. Nice. So I took a look at some of the papers that you've written, and you are spanning some domains, right? Computer vision, language, reinforcement learning, I think for control of robots to a degree, and finance. But out of all of those different types of data or types of areas of machine learning, which one really resonates with you and keeps you, super interested? Could be multiple, but
I think the bit which I'm most passionate about is this, what I described earlier as data efficient learning, which is not really tied to a specific application. You can do it in anything. But what excites me about it is that normally in machine learning, you might define a new CNN architecture, and then you go and you have a learning algorithm, could be backprop based or whatever, that trains your neural network to solve whatever task you wanted to solve, whether it's recognizing images or balancing the robot or whatever. But in this area that we work in called meta learning, then what you do is you try to get one learning algorithm to design another learning algorithm. So rather than you design the CNN architecture, you have a new higher level learning algorithm that designs a better architecture for you. Or rather than you program the backprop algorithm, you have a meta learning algorithm designs a new optimizer for you that is hopefully more efficient than the hand engineered optimizer that you might have had before. And so we use this kind of like algorithms, designing new algorithms. You can do various things with that, but one of the things you can try to do is to automate the design of more data efficient algorithms. And you could think about that a little bit like as a life normal, humans or animals learn over the course of the lifetime, but they also have perhaps an evolutionary time scale where like your animal species evolves to be better at learning. And so you have this like two levels of learning. And so now we have the higher level learning that's trying to improve the learning algorithm. And then within that, then you try to actually solve a learning problem. And so this is something which I think is quite exciting as a way to reach more advanced forms of AI. And so that's something I'm passionate about. In terms of the particular applications, I guess I enjoy computer vision a lot, mostly because you get to look at pretty pictures while you work on things. But yeah, I work on all sorts of different things. So for example, we have a long-running project in Edinburgh, which I'm just a part of, to be clear, but it's looking at automating oil rig maintenance using robots. So they have some very like rough seas over there in the North Sea of the UK, and they hope to be able to have robots run the oil rigs eventually, so that it's kind of safer and more cost effective than helicoptering people over every day. And so that's like one of many kinds of applications that we think about.
When you start talking about all the different fields of machine learning, I think one of the paradigm shifts that I've seen in folks who are just joining or just starting their machine learning career, it's this notion of, I've run a library and I'm doing machine learning, versus focusing on the fundamentals and understanding why those libraries work, how you should be able to extend them and apply them to different problem domains. Can you speak to that a bit?
Yeah, that's a good point. I guess for folks who are a little bit older like us, maybe, we didn't have all of those libraries in our day. So if you wanted to implement something, you had to implement it from scratch, and you couldn't dodge like understanding exactly how it worked. But nowadays there are so many nice libraries that are kind of pre-packaged for you. that there can be a little bit of a trade-off. Like you want to get something working quickly, and so you stick lots of libraries together, and then you can end up in a situation of not understanding exactly what's going on, and therefore not knowing how to fix it when it doesn't work, or how to improve it if you need to improve the performance level. So I agree, it's kind of a tough thing to balance, like how much to focus on the fundamentals so you really understand things more deeply, versus how much to just kind of stick libraries together and get something running as quickly as possible. I agree, it's a tough dichotomy.
But at your level, with the folks that work with you in your research lab, I'm sure there's an applied side. There is also, which is more of engineering versus the more theoretical research side.
Yeah.
Even with the folks doing the applied engineering, they have a very strong foundation as well, right? And how much do they dig into that foundation versus do engineering work? Just curious, actually.
Yeah, I mean, I guess both of my roles are quite cutting edge research related. So probably most of the guys who I work with are more on the side of like trying to understand all of the details.
Okay.
But in Samsung, for example, we are in the most basic research arm of Samsung, but there are other like more applied research arms who are just trying to, research the next best whatever speech recognition in your phone or whatever it might be. Some of those guys are a bit more like just trying to stick together the latest collection of libraries to push performance a bit more. But even in their case, like, if you are in a very competitive company, a Google or a Facebook or a Samsung or whatever, like you are still trying to push the boundaries of whatever you are doing to make your company have the best product. And so, even those folks in the most applied labs need to understand a lot about what's going on, so how to improve the things that they're working with and not just sticking them together. I think the key is probably to work out like when you really need to understand something and when it's sufficient to just stick the libraries together. And because of course nobody has enough time to understand everything to the maximum amount of detail. And so the key part of the wisdom to have is like which bits are worth spending the time to understand to the fullest detail, and when you can just kind of outsource it to an existing library.
Yep, that's actually very helpful. And I really hope as we spread, especially this interview, I would say for students in college, I would even say high school, just getting a picture of, hey, here's what you can do, but don't repeat some, I don't want to call them simple mistakes. They can be quite complicated if someone doesn't pass wisdom like this down. And can you tell us a bit about, you have a Turing Fellow status on your profile, and what does that mean for folks who don't know much about computing?
So this is to do with the Alan Turing Institute, which is the UK's National Institute for Data Science and AI. And they award fellowships to scholars who are at the forefront of these areas. And their goal is to kind of then encourage those people to give them the visibility to have influence in policy, for example, so that policy can kind of draw on data science inspired insights where appropriate, and as a route to networking and so on. And so in my case, I started out getting that status via my kind of proposals around data efficient learning and so on. And recently I have also been starting to look a bit more into things which people have been thinking about, like bias in AI. So if you have got a biased training set of some kind, you don't want a model that like reinforces some kind of problematic societal bias. So how to make sure that AI systems are fair to people of different genders, for example, to take one sensitive attribute, and how to make sure that they can kind of explain their decisions so that you not going to have it do something really weird in a black box way that you can't justify. So some of those things at the intersection of like AI and kind of social good, some of the things which I think about a little bit in that hat these days.
Perfect. Shifting a bit into coming back to your roots, right? Caribbean roots. And one of the things we try to highlight on the show is understanding, call it an advantage, all right? Or what unique experiences or perspectives do you get being a person of the Caribbean diaspora, and how has that sort of affected, just coming from that culture, how has that affected your career, I would say?
Yeah, I think Well, I don't know. Yeah, I guess in one thing interesting in Trinidad, I always felt it was quite a melting pot of like different people, different cultures, and so on. And so I think one thing that might have helped me is growing up in Trinidad and interacting with all kind of different people uh, has been quite good to help me to build a lot of collaborations and so on later on in the
Mhm.
career. So you have some people who might have had a little bit more, let's say, narrow upbringing in terms of like the society that they were in, and then when they meet diverse people that they need to work with together in a team, then somehow they like find it a little bit more difficult to be relaxed enough to interact with everyone. But yeah, you meet all kinds of people, interesting people in the Caribbean melting pot, and I think that helped me to be a very kind of relaxed and open person,
Mhm.
which then helped me to build a lot of good collaborations and good teams later on.
We had another guest on, Daniel, who's a principal researcher at
Yes,
Microsoft in
yes,
the
I know
UK
her
as
well.
well. And she mentioned that at your level, collaboration is actually one of the key factors of success in research. You want to expand on that?
Um, yeah, so I guess when I was a junior in high school, university, etc., I kind of had the approach that I need to train myself in all of this stuff, and so I'm
Hmm.
going to study everything myself and do it all myself. And if I rely on anybody else at any point, then this is somehow cheating, or I'm not picking up a skill which I want to pick up along the way. And there is some kind of value in that. If you drive yourself hard like that, you pick up a lot of skills along the way. But later on in the career, I realized that you definitely don't have enough time in one lifetime to learn all of the skills yourself.
Hmm.
And anyway, some people are definitely going to be better at certain things than you, and so it's very important to be collaborative, to find people who you can learn from, to strengthen your weaknesses, or find people who have complementary strengths and weaknesses from you to solve different projects together that would be bigger than what any of you can solve on your own. And so yeah, this is something which I kind of had a total about face on over the like longer term course of my career.
And did you see a significant sort of impact in the things that you tracked as metrics for your career, like
Yeah, I
paper
guess.
or just ease of expanding your network and things like that?
Yeah, for sure, totally. And what also networking was something which I kind of really disliked the idea of when I was younger, and I'm still bad at it, but I consciously try to practice it now. And this is something really handy to help you make the contacts that you can use to if you're a junior person, maybe you use networking to hopefully find yourself a role on a team later on. And if you are a more senior person and you've been networking a lot, then you use it to find people to build teams when you are like
Mhm.
tasked to build a team to put together some new project. And this is something which I was really bad at, but have been trying to improve on.
Nice.
uh,
Yeah, I've always been I don't think I was one of the smartest bunch. So like if you put both of us in CIC, I was a slacker, and I would be coming to you to ask for help, to be like, hey, how do I pass this exam? And I relied a lot on, I would say, that the smart folks in school, and I was grateful for that, to be honest. And that was one of my strategies in getting through school, is relying on other people to learn from. And I did notice that, hey, I can network easier than other people, so I use that to my advantage to make sure that,
yeah,
hey,
yeah, sure.
bring them along into something that I was better. They helped me sharpen my skills. So, I'm happy to hear that, networking is at the forefront of one of the things at the top of your career. Uh, Another question: how have you seen the evolution of machine learning, right? Being both like an accomplished scholar and now an industry researcher. I think one of the things I wanted folks on the call to understand about industry research, you're solving a business objective, right? It's not only about getting a new publication out, I would say. And how do you manage that constraint when you go to solve a problem out, you know?
Um, so I think there's a spectrum of flavors of different industry labs.
Okay.
So in some applied industry labs, it's very much like, okay, here is some business problem. We need a technical solution. Go away and figure something out. In other industry labs, like if you manage to go to DeepMind or something, they are more open-ended. or at least they are not necessarily trying to solve a particular business problem. They are trying to solve a technical problem that they hope will then, the business implications of that might reveal itself. And it depends a bit on what kind of research lab you go to in industry. One of the, in terms of the evolution of the field, one thing different is that maybe 10 years ago, there were maybe very few industry labs that had such kind of blue sky environment. And if you went there, then you were probably more likely to be working on a product. But nowadays, there is so much industry interest in AI that you can also get an industry job and do quite blue sky research. So that's one thing which has changed, like maybe over the last decade.
Wow.
And so exactly how you manage it depends on what kind of industry lab you have. In my case, it's reasonably close to the blue sky side. So, we talk to the people who are doing products and so on just to get inspiration about what would be helpful, but we don't have any particular specific requirements to help deliver a new product.
Understood. That must be nice, researching in I don't want to call it limited freedom, but in guided freedom, let's say.
Yeah.
So I looked at your papers. Last year, under your name, you put out 30 papers in some of the top conferences and journals. Can you give us any advice there?
Advice on how to publish 30 papers a year?
Sure, yeah.
Well, I think I was able to do that in partly because after a lot of effort building up good teams in Edinburgh and in Cambridge and Samsung, and partly due to a combination of having some particular technical expertise in certain things like meta learning and so on, and being a friendly guy with a good network. Because then what happens is, some other researcher somewhere who needs a particular technical input in some topic might invite you to come and help, and then you can go and help them solve a particular problem and then collaborate on the paper. So I think it's partly kind of a combination of technical expertise and a good network, and partly having built some focus teams in Cambridge and Edinburgh.
Nice. And so that, I guess, a more junior researcher, in terms of getting closer and closer to that, would be being part of a good team, networking as well, and still pushing on your technical competence, correct?
Yeah, exactly. So definitely networking is a good way to help you co-author papers. The more people you need to keep your own skills sharp as well. Otherwise, people won't have any motivation to invite you to collaborate with them. But then if you network a lot and you put yourself out there a lot, then you can kind of get invited to help in different collaborations and push up your research output in that way. And definitely, so that was something which I was very shy of when I was younger in my career. I never wanted to put myself out there and go and speak at conferences and workshops and all of that kind of stuff. But I wish I had done more of that in retrospect. And so, yeah, I advise people, don't be shy. You can put yourself out there and show them what you can do.
Nice. So four quick questions. How many papers do you read a day? That's something I think I've personally struggled with. But as a manager, do you just listen to people and they've read the papers for you? Like, what's it like at your level?
I guess my advice about that is, it's maybe how many papers to read a day is not quite the right question.
Okay.
The right question might be to have the wisdom of knowing what you need to get from each paper. So sometimes what you need to get from a paper is to understand a particular clever thing they did in an algorithm somewhere so that you can borrow that trick for your own algorithm. Sometimes what you need to get from a paper is just working out why it's different to your paper so that you can differentiate it properly when you are explaining the difference to reviewers. And sometimes what you need to get from a paper is a whole new perspective or kind of mathematics that completely changes your paradigm. And so in the first two cases of examples like that, you might be able to find out what you need to know in 15 minutes of browsing the right section of the paper. In the other example, you might need to kind of reread the paper 100 times over the course of 2 weeks to really bring about a total paradigm shift in your way of thinking if that paper is telling you something totally new. So I think it's really about knowing what's the right thing to get from each paper and in what way to read it to get what you need to get out of it.
That really helps. One of my grandfather, like researchers in computer vision, use like a big name. He always told me to ask questions of the paper, like read the abstract and ask, what is it? Ask yourself the question, what do you think it is that they're trying to say? And that primes your mind to start searching for certain things in the paper.
But it does also get faster with experience.
Okay.
When you are a junior person, you'll find that you try to read a paper and half of the words you don't know. And then you need to like track down the reference that they cite next to each of the technical words and read those papers. And in the end, you read a tree of 20 papers just to understand the first one that you started reading. And so there is like a certain extent to which like in the beginning, it's slow and later on it gets faster as you know more and more of the background. But that aside, I think it's more about, reading each paper in the right way to get out what you need from it.
Yep. So what two career tips would you give a high schooler, college person, and a professional researcher?
High school, study math. It's all useful. Even if your teacher doesn't have a good explanation of why it's useful at that time, you'll find out that it's useful later, at least if you get into AI. College people, start networking and putting yourself out there early. Never too early for networking. All of those like random other colleagues that you have in college will, later on turn out to be people who can give you intros to different companies or research labs or whatever. So make friends with everyone and start networking. And as a professional, maybe try to get the wisdom by then to figure out what you are good and bad at, and then find a team where you can, bring something that they are bad at that you are good at, so that the team values you, and then have other people who are good at the things that you are weak at to kind of complement you. So, and this set of tips are more or less all the things that I did wrong in my career. Tips from errors that I learned from. But yeah, I think that's
that's really valuable advice, and I'm taking that one and putting it in the bank. Last two questions. What are three principles you live by? At least now, right? I guess they change over time, right?
Maybe for career, find a job that you really love doing, so that then you don't ever feel like you are working. That is probably something which will make your life feel happier. In terms of managing the nuts and bolts of your career and your boss and so on, I try to under-promise and over-deliver where possible. So that way you don't have the feeling stressful to catch up with things that you have over-promised. And then, as I said, try to have a non-work activity that is fully mentally engaging. You need to, keep your eye on the ball while you are windsurfing or something, so that you don't fall over, and then you have no time to think about work during those hours while you're doing that, and come back refreshed.
Getting that balance. Nice.
Things I tried to do.
And last one, what three books do you recommend? They could be academic, they could be papers. Any thoughts?
Let's see. Guns, Germs, and Steel by Jared Diamond. I don't know if you came across that. It's a little bit like...
I've never heard that before. Okay.
History of the world in terms of some like macro scale things like development of gunpowder and flowing of diseases around the world and so on. It's good to get some humility to see the big trends that are happening. Freakonomics by Stephen Dubner is kind of a fun thing just to think differently about what's going on around you. And of course, Machine Learning, a Probabilistic Perspective by Kevin Murphy is a good kind of healthy eating book from the purpose of training your machine learning skills.
Machine Learning, a Probabilistic Perspective? Is that a recent book or an old book?
It was from 2012. It's still quite relevant to date. Even with all of the deep learning stuff, it will kind of help to understand why some of the things in deep learning are happening. But Kevin Murphy is making a new version of that book to be published in this year or next year, I think. So you can look out for the new updated edition as well.
Fantastic. And once again, we appreciate your time. And I've definitely learned a lot as someone who's pushing into a more senior, call it a research career or senior career in machine learning. And I hope the folks that are listening at any level will find some inspiration in your words of wisdom.